everyone. I'm Shreya. I'm a fourth year. I can't see you guys. This podium is so high for my height. What's the best? Maybe. Can't see my notes, but that's okay, I guess. I'm really excited to be here. I'm a fourth year PhD student at UC Berkeley, advised by Aditya Parameswaran. And I'm super fortunate to be able to work with amazing collaborators, JD, who's on the job market, Bjorn, Aditya, my advisor, and Ian from Montreal. All right, people are building software around large language models, and this is so exciting. I really think this is changing the world, honestly, not to shill. But, even though they're so powerful, they don't always work. And let me kind of give you an example, ground us with some terminology here. Consider this example LLM pipeline. Pipeline being an abstraction of some prompt that you kind of feed in multiple data inputs to. Doesn't really matter what's in the text here, but on one side, you might have an input data set, so some records, and then you might have a prompt, which kind of represents the instruction to the large language model. And often these instructions come with some do's or don'ts, some bespoke criteria that the user might want for their task. More concretely, here's an example of doing entity recognition or named entity recognition on a data set of tweets. Your inputs might be the tweets themselves. The prompt might say, do the entity recognition, write a sentence, and the bespoke instruction might be don't extract hashtags as entities. Now, if I were to run this, it would do this intelligent task on all of my inputs, which is amazing, and to evaluate it, I might kind of look at a table of all of my outputs. I don't really want to look at all of the outputs. That scroll bar is a little bit too much. But I might eyeball a sample here and there. One of them might look good. Another one might be bad. And I could kind of vibe check my way to some good outputs. I could try to identify which ones are bad, manually correct them myself, or retry the LLM. But this is not a very scalable approach, and it requires human expertise. It's not something that you could really apply to every single problem setting. So how do we think about a more scalable approach to evaluating these outputs? If only we had an automatic system that had a simple natural language interface where users could program some criteria. Okay, nobody laughed at my joke, but that's okay. People do use large language models to evaluate LLM outputs quite circularly. And it sounds weird. It sounds like, oh, we're like turtling all the way down. But it's shown promise, in research, of course, and also it's very popular in industry, in practice. I Googled LLMs, and the first thing that came up in my search history after I cleared it was LLM as a judge. So this is useful. People find it useful. But it begs the question, who really validates these validators? It seems crazy that we're abstracting this human-centered validation problem completely away from the human. So in this work, we pose this question, who validates the validators? And we contribute, we contribute an interface and broadly more like a workflow for aligning human judgments with LLM-powered validators, as well as doing a qualitative study where we learn some very interesting things about why people don't feel like, even if their assertions or validations are aligned on paper with their thumbs up, thumbs down feedback, they still don't trust them. And one such finding here is what we call criteria drift. People's very perceptions, evaluation criteria actually is a function of the nature of the LLM output themselves, which I'll explain towards the end of this talk, which is kind of crazy. All right, so let me describe EvalGen, the workflow. EvalGen is a tool that we built. It was built on top of ChainForge and can be applied kind of to any LLM prompt. So we start out by the user creating like an evaluator node that they can apply to their LLM chain in ChainForge. The EvalGen wizard will pop up and give the user one of three choices. Ask EvalGen to suggest some criteria based on the prompt, or have the user grade or eyeball some responses to get a sense of the criteria they want, or just write the criteria from scratch themselves. Suppose the user wants EvalGen to suggest evaluation criteria. EvalGen will come up with a small number of binary criteria that can either be evaluated with a code function, a Python function, or a large language model. Users can edit this, add to this, toggle between code and LLM, make modifications as they see fit. Once they finalize their initial set of validators, we take them to a grading screen. In the front end, the user is presented with an LLM output to grade as good or bad. They can give a thumbs up, thumbs down, so forth, keep going. In the back end, as users are grading, we are searching for good implementations of these evaluation criteria that align with their grades. So this could be different LLM prompts for each criteria, different Python functions for each code-based criteria, and so forth. Finally, when the user is tired, we saw in the studies that they got tired after like 15 or so examples, we take them to a report card page where we present them with the assertion that aligned most. Alignment is measured by F1 score, with their grades. And they can also see assertion implementations that were not selected. They can see a confusion matrix and all sorts of data analysis that they may or may not want. Who knows? Okay, so I just showed you how people can generate evaluations based on a sample of the LLM outputs. They can also scale this up to their entire pipeline, their entire data set, by running those chosen evaluators on the inputs they didn't grade and eyeball this table view of how each assertion performed. So we built this tool and we put it in front of a number of 9 AI engineers, and we asked them, okay, use this tool. Tell us what you think. Does this come up with good LLM-powered validators? We gave them a sample task, the same named entity recognition on tweets task, or they could come in with their own task. And people really loved EvalGen as a starting point for coming up with evaluations. It alleviated this kind of blank page problem, which is not really surprising. But what was very surprising to us is that even though they got evaluations that aligned with their grades, they still didn't trust it. The Likert scale scores were all over the place, some with 6s, some with 1s, 2s. And people said, I can't even begin to think about how I would put this in production. I'm super skeptical. So I'll cover a couple of reasons for kind of why we hypothesize this based on our qualitative study. The first is around this idea of criteria drift. So when people grade outputs, this kind of spurs changes to their evaluation criteria. Unsurprisingly, maybe they want to add new criteria based on new failure modes they observed as they look at examples. But what's kind of interesting is they might also want to reinterpret the definition of criteria that they already set based on how well the LLM performed. And let me give you a concrete example of this here. So I have this same named entity recognition task, and the criteria is not to extract hashtags as entities. The first time that somebody might encounter a failure mode of this, they might say, yep, this is bad, I'm gonna mark it as a thumbs down. The second time they encounter this example, so Colin Kaepernick is a very famous American football player, they might also grade it as bad because there's a hashtag that was extracted, or so they thought. And then they thought, I said no hashtags as entities, but I think the LLM might have done the right thing here. And once they see this occur more and more, they actually want to change the criteria to be, for example, no pound sign instead of extract no hashtag. Go back and they would change their grades and then hope that EvalGen, just magically found this assertion for an entirely different criterion. So this is very interesting. What does it imply, right? Sense-making is a natural part of grading, and maybe it's impossible to expect people to just anticipate all their criteria up front, as one of our participants said. And if you work in education, maybe this is not that surprising as you grade students' exams. You're coming up with rubrics for how to score them. Certainly, those rubrics change over time. You might change them as you observe many students making the same mistake. So there are a lot of parallels to draw there. A second set of insights that we had was around the very nature of the evaluation itself. We found that people wanted both code-based and LLM-based evaluations, but they thought of them differently. And especially because everybody knew how to code, they didn't want to be giving thumbs up and thumbs down on outputs that were evaluated by Python functions. They just wanted to see various Python functions and pick which code map to their own mental model of what the criteria should be. So you might be wondering, okay, maybe you could just have 2 separate tools for this, and maybe if people know whether they should use LLM evaluators or code-based evaluators, then just direct them to the right tool, the right interface, and call it a day. Most of the time they do know, but sometimes it's completely not intuitive. Some assertions you might trivially expect to be implemented in code don't actually work. For example, if there is a typo in the input tweet, the LLM in the pipeline might correct the typo to come up with the entities that were extracted, and a code-based assertion that would just check whether the entity, the string, was present in the input, that would fail. And that's not what we want. But if we asked an LLM to evaluate this, it would probably say that's totally fine. It would match up the typo against the entity name without the typo. So I just talked about two set of insights that we got from the qualitative study. And before I conclude with the final takeaways, I want to mention we put up our preprint a couple of months, maybe 3 to 4 months ago on arXiv, and we were very excited that a lot of people resonated with the problem. A few companies kind of implemented the EvalGen workflow in their products, which is quite exciting. I'll highlight two of them. One called AutoBlocks. They built an EvalGen workflow similar to ours, not exactly the same, but they were very kind to call out our paper in the blog post, and they deployed this and saw some large number of accuracy improvement, which is very exciting to us as academic researchers. And also LangChain built a product offering around LLM-powered evaluators, largely incorporating humans in the loop in a similar way as we do in EvalGen. So finally, I want to conclude with some high-level overall takeaways. LLMs don't always work, especially when you want to do things at scale, so we want to have validators. But LLM-powered validators in a vacuum might not really tell you if the outputs are actually matching your own internal expectations. And people's criteria changes as they observe more outputs and as the pipeline architecture changes, as models change, as prompts change, as people add all sorts of fancy architectures to it, like RAG. Grading, sense-making always has to be a continual process and inform validators. And with that, thanks to everybody that I worked with, you can reach out via email here, and JD is on the job market. I will plug it one last time. Thanks so much.
Thanks. Great. Thanks, Shara, for the amazing talk. I'm also very impressed by you just not looking at the notes and did the talk. This is Wesley from CMU HCII. Very super cool work. Definitely bringing human-centered approach to thinking about complementing the LLM-powered validation. My question is, so the title is who validate the validators, right? My question is who validated the validators of the validators? Because from crowdsourcing research, we know, human, they also have disagreements, sometimes they make mistake, and if you actually, and it's super cool when, some company, they actually adopt the workflow, but then when you have a lot of human, they're doing annotation, they might have mistakes, and also they sometimes disagreement if, especially for more subjective tasks, right? For example, maybe 95 people saying, okay, maybe this output is not that harmful, but maybe 5% people from marginal community, they're like, well, this is actually harmful. How do you actually empower or surface those insights within the validators of the validators?
That's a great question. So we talk a little bit about this in the discussion, but a few people in the study immediately said, oh, this has to be a collaborative interface because my product manager is a person that I would ask if this is right because I don't know myself. Or 3 or 4 of us have to have a consensus to make a decision. I think there's a lot of parallels in crowdsourcing here, right? We've built crowdsourcing pipelines before, and we know that crowd workers have disagreements, and there are several algorithmic techniques as well as interface techniques to resolve that. I think it would be really interesting future work to explore that.
Yeah, thank you. I'll chat more.
Hi, this is Jin Yu from Quebec AI Institute, so it's very impressive work. I just have one small questions about given the challenge of those different personal preference of the different validators, do you think there's a universal ground truth can ever realistic achieved in large language model evaluations?
What I like about the EvalGen approach is that it's pretty easy to create personalized, customized evaluators. We kind of adopt the notion that there's no one-size-fits-all evaluator. Your NER pipeline might be different from my NER pipeline because we just want different things. But I don't know if this fully answers your question. I think in the future also we're going to have customized evaluators. And the question becomes, okay, how do you help people come up with those effectively, feel confident in them, and deploy them and have them actually catch mistakes? So.
Thank you.
Can we get the next speaker to set up during the next question, just so we stick on time?
Hey, Shreya. Anna Kawakami from Carnegie Mellon HCII. Really cool work. Thanks for giving the talk. I was curious about your thoughts on the potential biggest barriers to having this tool that you created work for like impacted community members or frontline workers who don't necessarily have expertise in AI. I understand the study was with AI practitioners, but if you were to imagine that there's this other demographic of people working on it, what do you think might be the challenges we need to overcome in order for the process to work well for them?
Yeah, also a great question. I think the ChainForge paper has a little bit of discussion on this, if I'm not mistaken. But one thing, I think we got low scores from people because they were experts. They were like, just because I validated this on my sample, like I know that there's data drift in production and it's not going to work when I deploy it. And I worry that having done such a study on people who are not familiar with AI, we might have like gotten high scores and then said we've solved the problem and moved on. So I'm curious now, like now that we know this and we can build around solutions around criteria drift, how would they fare in user studies where the people don't actually know how to use AI and ML? That would be super interesting to find out.
All right, why don't we thank Shreya again? Thank you.